Hi, this video is going to show you how you can use spot levels or points that have had heights allocated to them in order to generate a contour diagram and also to generate a three-dimensional digital terrain. Now, this drawing has been supplied by Richmond TAFE and TAFE College or University in New South Wales, Australia, and this exercise is for students to allocate actual values to these points, which has already been done. So let's zoom in firstly and we'll have a look here. There are some little points. I'll just undo that. We'll just select a box around here. You can probably just see this point. I'm going to right click on points and choose select all the same entity because I wanted to pick all the points in the entire drawing, which we've now got somewhere. Zoom out and we'll see that we've actually highlighted all these points. I'm going to change those points so that they're easier to see for this video. So I'll make them 2 millimeters thick and I'll make them red. It'll make it a lot easier for us to actually see what we're doing whilst we're drawing. Now, each one of these points has a height value. Okay, so each one of these points has been designated a height. This is the highest point and down here is the lowest point. There's not a lot of difference between these two. In fact, down here, this point value is only 9 meters 650 millimeters, and up the top here it's only 10 meters. So the difference between the highest point and the lowest point is only 350 millimeters. Now, the person who drew this has taken this chart or this table, and they've used the values as allocated here, and they've transferred those values to each one of these points by using this command here, which is where you actually set the heights for each of the objects that you wish to include in your calculation of your digital terrain model. Now, we're just using points, but you could equally use curves and lines to represent height values. If it were a line, then that might be good for something like the top of a retaining wall that has a constant level to it, and you would draw that line and that line would represent the top of the retaining wall. In this case, by the way, I'm going to come down and limit what we can select. I'm not going to select anything except for points. Select OK. That'll make it easier for me to pick the points when I use this command to actually set them. So the way they were set, let's click on one of these points here, for instance. Well, it's picked on the line, which is select the point. Okay, so point, select here. The digital terrain or the point in this instance has been set a value of 10,000 millimeters. So that's 10 meters high, and that's all that's really required is to click on the point, type in a value and click set height. Each one of these has already been done, and each one of these, I've noticed that this user has actually included their own piece of text. However, it's not necessary. You can, and we'll choose it again, you can just click on show heights and it will place text next to each one of the points that you have allocated a height value to. If you don't see this blue text, then clearly you haven't allocated anything or any value to the point, and that's a good indicator that you need to assign a value to it. So that is worthy of noting. We're now going to select all of the points, and I just used a selection process of right to left and it grabbed all of the points outside of that window. I'm now going to choose the next step in the process, which is to insert a digital terrain model. Digital terrain model, or a DTM, is like a mesh. So I click on here, and that mesh is a representation in triangles, or a whole mesh of triangles that represent the surface of that land. The contour point spacing is not of value here because we are just using points. This is, I believe, used for representing, if we were to draw a line, it would basically say, well, how far apart are the points along that line that we would be calculating from. Normally you'd probably put something like 500 or a meter or something of that nature so that it would calculate a point every meter along the line and use that value along that line. The mesh control here is important. This is how many elements, so how many triangles are we going to include in the mesh of the entire block of land, or alternatively, what sized elements are we going to use? Now, an element size of 100 is ridiculously small and it will take your computer a very long time to work out. An element size of around about 1,000 or 2,000 is probably pretty good for a block this size, which is approximately 30 meters long here. You can see that here, 30,000 millimeters by 18,000 high. I'd probably be setting that at maybe 2,000, something like that. It doesn't really matter too much, so long as it's greater than 1,000, in my opinion. Or alternatively, the number of elements. So how many is a total number of elements? How many triangles in the total are going to represent this? So let's just do this a couple of times. But before we do, we're placing all of the digital terrain model onto its own layer. I've specified a layer called DTM1. These layers already exist in your software. They're predetermined, but you can type in any other layer. You can choose a layer from your list, or any layer will do really, but they're choosable. And then the color is color 7, and in this case color 7 is green. So I'm happy with green. There are two choices for inserting your digital terrain model. If you wish for a rectangular boundary around your block of land, but your block of land is not rectangular in shape, then you would use this option because it will actually draw a rectangle around it. In this case, we are already in a rectangle, so we can just use insert DTM. And that DTM is inserted very, very quickly, as you can see, and these are the triangles or elements that make up this particular digital terrain model. I'm going to undo this now, okay, and we're going to redo it using a different value so that you can actually see the difference between them. So in this case, we didn't choose either number of elements or element size. We just left it kind of blank and it kind of worked itself out. However, if I choose number of elements and I say I only want 50 elements in total, let's hit insert DTM, and you'll notice they're much larger now. So these triangles are much larger than they were in the previous setting. And again, we'll undo, repeat the command, and we'll set it to say 500 and hit insert DTM, and now you see they're smaller. Now the smaller they are, the more accurate your end result will be, but the slower your computer will be working at. Okay. Now the next step is for me to show you what's actually happening in the background. This is a three-dimensional model, so I'm just going to go up here and have a look. You don't have to do this, but we're going to go have a look at the isometric view. I'll zoom fit this so you can see that at the bottom here we've got our sheet of paper with our little crosses on it, and then up here we've actually got the digital terrain model, and this model is in 3D space. It's literally 10 meters, and well, this point is 10 meters above the ground level, and this one here is 9.650 meters above the ground level. So each of these points on here has a three-dimensional value, or a Z height. We will look at it on side on, so I'll just choose one of the side elevations. Left view will be fine, and you can kind of see, if I zoom in on this, that we've got a height difference between it. So we're kind of looking at it side on. There's not a lot of difference. That 350 millimeters between from one end of the site to the other isn't a lot. It's not a steep site. Let's go back to our top view and fit it to the screen. Now what I want to do is draw the curves that represent the contours, but before I do that I'd like to choose a color to draw it in. I'm going to draw it in blue and probably a line weight of say 1 millimeter. Okay, so it's going to use this active color down the bottom here, and all I've got to do is choose the generate contours or insert contours command, and here we specify the height difference between each contour. So I know that in this student exercise you're being asked to place these contours at a height spacing difference of 100. So place a contour in every time the height changes by 100 millimeters from the previous contour. And so I'm just going to accept by typing that in, and I'm just going to hit OK, and you'll see that over that 350, so from this point we've got 1, 2, 3 contours, and each one of those represents a height difference of 100 millimeters. If I undo that and I redo the contours, this time I'm going to put it in at 20. Okay, 20 millimeters is the height difference between each contour that I'm going to insert. And then every 5 contours we're going to have them drawn automatically at a slightly different color. It will choose the color. And I don't know what size text we're going to use, but this is the text size that would be drawn along the curve of the contour that actually shows you the height. I'll probably go scale that and say make that, oh gosh, probably only I don't know, maybe I won't scale it and we'll make this something big enough to see. Hopefully 500 millimeters would be big enough for us to see. I could double click on this and find out what that is, but not too fussed at this point. So there we are. We've now got the curves are in place. Each one of these represents a difference of 20 millimeters, and yes, this is the text that has been drawn that represents each one of those contours. If we were to flip back to that 3D view that we were in before, so have a look here, we can now see that the contours themselves are drawn flat on the sheet. So flat on the ground at Z equals 0, and this element still sits up here. If I want to, I can make sure that I can select everything again. Everything is now selectable. I will right click on the contours, and I'm actually going to say hide all of the same color, and we can see this a little bit more easily. So that's it. That's the process by which you generate contours as an automatic routine based on these spot levels that we've inserted. Let's just flip back to the top there and zoom fit. And it really is that simple. If you find that your contours do not look correct, they look weirdly out of shape, for instance, let's try that. Let's actually try something here and have a look at what happens when the contours are completely incorrect. So I'm going to go to my heights. I'm going to click on this point, and rather than it being here, I'm going to assume that it's 0, so it's way down below. I've accidentally forgotten, for instance, to give it a height. Okay, now actually you can see that it's 0 because it's showing me that there, but I'm going to assume that I've accidentally missed it. I don't want to see any of these. I'm going to throw these ones away. So I'm going to select all of the same entity type, all these curves, and just delete them. I'm going to only pick the points again. We're going to go through this process. Pick the points. Okay, this time we'll generate our DTM, and I'll use all the same settings that I used last time, and it will generate the DTM based on these points, except that I've switched that color off. Okay, so I can't see them at the moment, so I'm going to right click and unhide everything. So there they are. Okay, it's replaced the old DTM, by the way. This is a new DTM. It's been placed on the same layer. I believe that's the case anyway. And now if I insert contours using the same concept, it will put them in. And you can see it's dived way down here, 10 meters down basically, there's a hole. Okay, and this is not what you would be expecting. But if we look at this in 3D, you can see what has actually transpired, what's gone on. Okay, and there it is. It's way down there, and a bit hard to see from this angle, but we've basically got a bit of a vortex happening. It's all this land is collapsing down into a vortex into the center of the Earth. If we look at it from this angle, that's it there. So you can kind of see it just it's pulled it all the way down and back up again. And it's an approximation. You'll notice that it hasn't reached the bottom. Okay, so all of this is based on an approximation of points. If we wanted it to be more accurate, then we can use a different setting in here. Okay, by breaking this into smaller elements, smaller sizes, then the calculations will be finer. But you will find for landscape purposes that this will be perfectly adequate, and because you're not going to get that kind of extreme variation in your designs. And that's all there is to it. I hope that has helped.